Okay, this is the June 2011 Unit 2 paper. It's a non-calculator paper. Can I remind you that on this particular one, it's worth 60 marks. Even though it's non-calculator, you need to go through and you need to show full working on the questions. The first thing we're going to remind ourselves of is the fact that we have a formula page. If you come up with any of these particular skills in the exam, do not forget that the formula page is on there, and make sure that you're using that as best you can to make sure you can get as many marks. So that formula page, become familiar with what's on there. Right, question 1. Fantastic first question to start off with. We're going to take some marks out of this because it's work out the area of this triangle. And I know the area of any triangle is base times height divided by 2. That's the area of a triangle. In this case, the base is 6. The height of that is 5. That's the perpendicular height, remember, the straight up and down height, divided by 2. And now I say 6 times 5 is 30. Half of that is 15, and my units are centimetres squared. And that's the first question. Easy. Question 2, a little bit of algebra. Again, we're right at the start of the paper, so they're going to be the easier algebra skills. We're not looking at and reminding ourselves once we get past halfway about difference of squares and things. They're the easy algebra skills. So if we have a look here, first one is simplify, and it's an algebraic expression. We're going to look for collecting the like terms. So to simplify that, I've got, well, I'll take the x's out first. So I've got 2x's plus 5x's gives me 7x. I've got 3y, so it's a positive 3y. There's no other y's there to collect together. I'm collecting like terms. And then here, I have a negative 4 and a positive 7. Remember, when you're dealing with negatives in this way, it's easy to think of temperature. So I start at minus 4 degrees Celsius, it gets 7 degrees warmer, it becomes positive 3. So I end up with a plus 3. And that's worth 1 mark for that, going through and getting each of those correct. The second one is then about factorising. Factorising is when we put it back into the brackets. So here, I'm looking to remember, grab a term out of each of them that's the highest common factor that I can put at the front of the bracket. So here I've got a 2 and a 4, and the highest common factor of 2 and 4 is the number 2. 2 times 1 gives me 2, and 2 times 2 gives me 4, so I'm going to take out a 2. I'm also going to have a look and see if there's a common letter part for each one. So in this case, I have x squared and an x. And if I was to grab one from each and make sure I grab the same, I can pull out an x from each one. There's x squared there, which is x times x, but there's only an x by itself there. So I end up with 2x is the highest common factor. And once you've got that, the rest of the question becomes very easy. 2x times what gives me 2x squared? 2x times x gives me 2x squared. That's how I get the first term. And then 2x times what would give me minus 4? Well, 2x times 2 would give me 4x, so 2x times minus 2 would give me minus 4. You'll actually get, for that question, 2 marks. 1 for just getting the highest common factor, and then a second mark for getting the correct part inside the brackets there. And then part C of this question then talks about expanding and simplifying. So we have a look at expanding and simplifying. In this particular one, I've got an 11, and then I've got a minus 3 bracket x plus 2. That's the expanding. Expanding talks specifically about brackets and multiplying them out. So what I'm going to do is I'm going to have a look here, and I'm going to say I've got 11, and then there I've got minus 3 times by x, which is minus 3x, and here I've got minus 3 times by 2. 3 times 2 would be 6, so minus 3 times 2 would be negative 6. And so I end up here with 11, take away 3x, take away 6. Now that's the expanding part, so there's 1 mark for doing the first step of the question, expand. The second mark comes for then simplifying, and here I've got negative 3x, which is just there's no other x's, but then I have a positive 11, take away a 6. positive 11, take away 6, gives me positive 5. And that's your answer. If you had have written that as 5, take away 3x, it's still the same, as long as what you've done is you've got that negative 3x and you've got a positive 5. As long as you keep the sign that's in front of it attached to it, you can rearrange the order that you put them in, so either of those are correct. And then part D is expand and simplify, but when we see this, as soon as we see these double brackets, we should be thinking FOIL. On the last one we looked at it and we did the multiplication with the waves. Here we're thinking FOIL, which is first x times 3x, which is the outer x times 7, which is the inner minus 6 to negative 6, be very careful, times by 3x, and the last, negative 6 times by 7. And once I do FOIL, it becomes some simple multiplications of terms. X times by 3x is 3x squared, worst squared ever. X times 7 is 7x. Negative 6 times 3x. So 6 times 3x would be 18x, but negative 6 times 3x would be negative 18x. And then 6 times 7 is 42. Negative 6 times 7 is negative 42. I then take those, put them together. 3x squared, add 7x to positive 7x, subtract 18x, minus 18x, minus 42. So I've expanded now. That's my whole skill of expanding, is using FOIL. I now need to do the second part again, which is and simplify. X squared, there's no other x squared, so it's just 3x squared. 7x, take away 18x. It's 7 degrees Celsius, it gets 18 degrees colder. That's going to be pretty cold. It's going to go past 0 and all the way down to minus 11x, and then the minus 42. And there's another 2 marks for that question. That whole question on algebra is worth 7 marks of this entire paper. That's an awful lot of marks. You need to make sure you can do those skills of simplifying, factorizing, expanding. They are key skills that you need to be practicing. And when you break it down into these little steps, they become easy skills. Right, we go on to question 3. Now, we hadn't really looked at this before, but express 48 as a product of its prime factors. Now, when you see a product of prime factors, that's when we start doing these factor trees. So what we have is we have the number 48. And I'm going to sit there, I'm going to think about how can I break that down. Now, whenever I'm asked to break something down or simplify it, I'm always going to look first and foremost to see if it's an even number, because if it's an even number, I know I can do 2 times something. It just makes my life easier. Always check that. 2 times 24. And I have a look, and the number 2 is a prime number, so you circle it. Then I'm going to check that it's an even number again, which it is, so 2 times 12. Again, 2 is a prime number. Then I'm going to check that it's an even number again, 2 times 6. 2 is a prime number. Then I'm going to check that it's an even number again, so it's 2, I'm sorry I've gone over that, times 3, which are both prime numbers. What I've done there is I've kept breaking that number down until I've only got prime numbers left. And then what I end up with is 2 times 2 times 2 times 2 times 3, 2 times 2 times 2 times 2 times 3 actually gives me the number 48. So what I've done is I've now expressed the number 48 as a product, which is all these multiplies, of its prime factors, 2, 2, 2, 2, 2, and 3. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 3 is 48. You could also simplify that. You're not asked to. You don't actually get a mark for it in this question, but you could simplify it, because there I've got 2 times 2 times 2 times 2, which is 2 to the power 4 times by 3. That there is just a simpler way of writing that. And that's how you express numbers in a product of its prime factors. Now, the next question, it follows on from prime factors. So there is actually a way of doing it by having a look, and it's asking when will buses to Exeter and to Plymouth next leave the bus station at the same time. What you're trying to find there is the lowest common multiple. It's the lowest time that both of these buses. So this bus to Exeter leaves the station every 20 minutes. So it leaves at 8 o'clock, it leaves at 8:20, it leaves at 8:40, it leaves at 9 o'clock, it leaves at 9:20, and so on. So they're the multiples of 20 minutes that the bus leaves on. The bus to Plymouth leaves every 16 minutes. So it leaves at 8 o'clock, at 8:16, at 8:32, at 8:48. So you see that's happening. And the question's asking, when do those two buses pull in and leave at the same time again? So that's our lowest common multiple. It's the first time that those two patterns will actually be the same time again. Now you can do that using these prime factor trees. I'm going to do it in a slightly different way. I'm going to do it in what I think is, for this type of question, a much easier way for you to do it. It can take a little bit more time for some questions, but you'll see what I mean. So Exeter, that leaves at 8 o'clock, and then it leaves at 8:20. I'm just going, adding 20 on each time. At 8:40, at 9 o'clock, at 9:20, at 9:40, at 10 o'clock, at 10:20, and you can see that it keeps on going. And I might have to keep on going. So that's my first list. That's when that bus keeps leaving. The Plymouth bus does the same thing, just leaves every 16 minutes. So it starts at 8 o'clock. That's the first one. And then I go 8:16, 8:32. I'm just adding 16 minutes on each time. I don't know how you add on 16, but I'm just adding 10 and then adding another 6 on. So I've gone 8:42, 8:48. And then 8:58, 9:04. And then 9:20. And then 9:36. I could have probably stopped here because what I've done is I've found that they both leave at 8 o'clock, which it gives me in the question. But then here, they also then both leave at 9:20. So that's the first time that the two buses leave at the same time. It's the lowest common multiple. It's the lowest value at which both buses leave at the same time. And that's all that is. So your answer there for 3 marks is to literally do a couple of lists of times when the bus is leaving and then think, when do they match up? And it's at 9:20. Be very careful in those simple calculations because you don't want to make a mistake. But the answer, of course, is 9:20 and it's AM. It's written, if I'm writing 9:20, I write it as AM. Question 4, a percentage question. It's on a non-calculator paper, so it's going to be a simple percentage calculation. We need to use our mental skills of percentages. She's buying a ring, it costs £60, she pays a deposit, which means she gives some cash over, work out how much she paid as the deposit. It's not asking how much she's got left after the deposit. This question is just asking how much does she pay as a deposit, and it's 40%. So the question is, what is 40% of £60? We're just talking about rings and things like that. So here, I know that 100% is £60. The amount she starts with is £60. I know that I can do some simple calculations. 10% is then just £6. 40% is going to be 10% plus another 10% plus 10 plus 10. So that's just 40%. So 4 lots of that, which is 24. And actually, you know what? I've just got 2 marks because that's the final answer, is £24. It's not asking me, and I'm reading carefully to make sure it's not asking me to say how much has she got left to pay, which it could ask. That's the question, and that's what the answer is. So it ends up as that. Now I have said before that this question on the Unit 2 paper will always be a straight line graph. So what we're going to do is we're going to look for the straight line. We're going to look for the pattern that occurs, which is going to help us. We're going to draw the graph of y equals 4x plus 2 from x is minus 1, all the way to 3. So minus 1, 0, 1, 2, 3. That's x and that's y. So I do my table of values first. I then do some substitution, and because I like to do things the easiest way. I'm going to do substitution using 3. So 4 times 3 plus 2. 4 times 3 is 12, plus 2 is 14. And then I'm going to do 4 times 2 plus 2. 4 times 2 is 8, plus 2 is 10. Then I'm going to do 4 times 1 plus 2. 4 times 1 is 4, plus 2 is 6. I'm going to stop there because actually I can see what the pattern is. I can see the pattern here is it's changing by 4 each time, which, if you have a look, is 4x. So it changes by 4 each time, every time. So this is going to be 2, and that's going to be minus 2, and I don't even need to do the calculations for that. I can just fill it in. And then, to get the rest of my 3 marks for this question, I'm going to plot the points, minus 1 and minus 2, and I'm being careful that I look at the scale carefully. 0, 2, 1, 6, 2, 10, 3, 14. If I've done it right, I get this nice straight line, and all I do is get a ruler, and play dot to dot. I don't have a ruler, so if you didn't use a ruler, you get 0 marks, just so you know, so make sure you do use a ruler for that, please. But that's it. And then, done. The next part of the question says, write down the equation of a straight line that is parallel to y equals 4x plus 2. What that means is that this steepness of it, that this stays the same. So actually I'm trying to come up with a line that runs parallel. So this part of it isn't changing, which means the bit that's changing by 4 each time doesn't change. It still goes across and up by, so it's going across 1, up by 4, across 1, up by 4. It's doing that each and every time. What changes is this second part of the number. Y equals 4x plus 2. That's the y-intercept. All that's doing is that's saying the line runs in the same direction, but I'm going to change where it crosses over the y-axis. So I'm looking at the y-intercept. In this case, we saw that it's plus 2. Plus 2. So if I wanted to talk about the line that passes through here that runs in exactly the same way, what I would talk about is I could talk about that as being the line y equals 4x, but instead of plus 2, the y-intercept being a positive 2, the y-intercept becomes a plus 8. That's parallel because the gradient hasn't changed, but I've just changed the y-intercept. So as long as you wrote y equals 4x, and then you could have done plus or minus any other number at all. In fact, you could have just done y equals 4x, because that would have had 0 there, which means it's just the line that's running through the point 0. So it's that parallel line. So as long as you had y equals 4x plus or minus something, then you've got a line that's parallel. The next one, it says write down the gradient of a straight line that is perpendicular to y equals 4x plus 2. Now, when we talk about perpendicular, it's the exact opposite of a right-angled line. A right-angled line, a parallel line. A parallel line runs in the exact same direction. A perpendicular line is one that will cut across at 90 degrees. So it cuts across, it's sort of the exact opposite of parallel. Parallel run next to each other and never touch. Perpendicular crosses together at 90 degrees. So what we end up with here is I need to come up with the gradient of this line, and I need to be able to write it down. Again, this number, where it crosses over, actually makes no difference. So I'm just trying to come up now with a number, with a value. So y equals something x plus or minus something else. It doesn't have to go through a certain point. So I can come up with whatever I want for my y-intercept. So that's my gradient. That's the steepness or the slope of the line. That is my y-intercept. So in this particular question where it's asking for a perpendicular, I need to work this out. Now the way that happens is that what it is I'm actually, to make it perpendicular, looking for a value that when I multiply 4 by this value, it will give me -1. So what I do is I just go the reciprocal. Now if you remember back to fractions, the reciprocal is where I take 4 and I swap it. So 4 becomes 1/4. That's the reciprocal of 4. But because it's a positive value, I also need to change it to negative. So that is now the gradient of the perpendicular line. So I have negative 1/4 x. You see, all I've done is I've just put it over 1, done the reciprocal, and then changed it to a negative. That is the perpendicular gradient. And this here again, because it doesn't ask for that in particular, you could have anything. So it's y equals negative 1/4 x, and here you can have plus 10, minus 1,000,000, nothing, it doesn't matter. It's not asking for a y-intercept, it's just asking for that. That's the challenge, is to come up with the gradient. So the gradient is minus 1/4. Okay, here we go, floorboards. The diagram shows, just quickly, it's got the asterisks there, so you need to be very clear in your working. Shows a plan of Mrs. Phillips' living room. She's going to cover the floor with floorboards. 1 pack of floorboards will cover 2.5 meters squared. How many packs does she need? You must show your working. Now, that means we need to work out area of that shape. That shape is one of those compound shapes. It's actually a shape that's made up of other shapes that we can find the area of. So I'm hoping that you should look to cut it either this way, which gives me a rectangle and a rectangle, or you can cut it across this way, which again gives me 2 rectangles. Either way, as long as you come up with 2 rectangles, then you can sit there and you can do that calculation. I'll just cut it down here. So I'm going to find out the area of this rectangle, the area of this rectangle, add them together. That will give me the total area of that, of the room, of the floor of the room. So here, this one's easy. This is base times height. That's the area of a rectangle. In this case, it's 2 times 5, which equals 10 meters squared. That was an easy one. The next one, though, if I'm going to do base, again, base times height, well, actually, I don't have the base. I know the whole room is 6 meters in length, but what I don't have is just the length of the rectangle that I'm trying to calculate the area for. So, if I know the whole room is 6 meters, and I know this little bit is 2, then I know what I've got left here is 2 meters, so that must be 4 meters, which means then my base is 4 meters times by the height, which is 2, which again becomes 8 meters squared. So in total area is 10 plus 8, which is 18 meters squared. It's the first part of the question. The question is not just to calculate the area, the question is to go out and work out how many packs of floorboards are needed. Now each floorboard covers 2.5 meters squared, so if I have 1 pack, I have 2.5 meters. If I have 2 packs, I have 5 meters. If I have 3 packs, I have 7.5. If I have 4 packs, I have 10, so 2.5, 2.5, 2.5, and I can do a running total down here. That will cover 2.5, that would cover 5 meters, that would cover 7.5, another 2.5 floorboard would cover 10 meters squared, so you can see how much I'm covering here. Another 2.5 would cover 12.5, another 2.5 would cover up to 15 meters squared, another 2.5 would cover 17.5 meters squared. So you can see what I'm doing. I'm just looking at each extra pack of floorboards I buy. I can cover a bit more floor. Another 2.5, and I can cover 20 meters squared. So you can see how that happens. And a little table like that is just going to help you. You could have just done 18 divided by 2.5, work out what it is. But you can see here that if I buy 1, 2, 3, 4, 5, 6, 7 packs of floorboards, I'm actually going to be half a meter square short. So I actually need to buy 1, 2, 3, 4, 5, 6, 7, 8 packs of floorboards so that I've got enough to cover the entire floor. So you see what I've done there? I've had to go more floorboards than I need, but I don't want to buy too many more packs than I need. So the answer here is that I need 8 packs. And that's your answer. See you guys when you do that. Okay, having a look at coordinates, we talked about midpoints. Midpoints is the middle of that line, and there's an easy way of working out where the middle of that line lies. All I need to do is I know the coordinates of A, are 3 and 8. I know the coordinates of B are 7 and 5. So to find the midpoint of the x-coordinate, so to find halfway between here and here, find that, then all I do is 3 plus 7 is 10, and I divide that by 2. Gives me 5. So the midpoint between 3 and 7, that's 3, that's 7, the midpoint is 5. So I know the coordinate of that is going to be 5, the x-coordinate, and I do the same for the y-coordinate. 8 plus 5, the y-coordinates added together, gives me 13, and I divide that by 2, means I get 6.5, 6.5. So I end up with a midpoint there of 6.5. And that is how you calculate the midpoint of two things. Add them together and divide it by 2. If you think about it, we do the same thing when we're looking at median. If you're between two numbers, you add them together and divide it by 2. When you do midpoints for estimate for the mean, the midpoint of an interval, you add the size of the interval up, so you do those and halve it, so you find halfway in the middle. So what we're looking at is we're looking at finding halfway points. So add the two x's together, halve it, add the two y's together and halve it, and an easy 2 marks. That's 2 marks for that particular question. We've got some more algebra, but this time we're sitting here and we're looking at doing some algebra involving indices, or powers. So when I simplify the first one, I'll just make it a bit bigger because I can't really see that. When I simplify the first one, I've got p to the power 3 times p to the power 5. What you need to remember is when the base is the same, the base stays the same, and we add the powers, and we get to the power 8. And the reason that happens is because I've got p to the power 3 times by p to the power 5, which means I've got 1, 2, 3, 4, 5, 6, 7, 8 p's all multiplied together. So I end up with p to the power of 8. The same happens here, except when I multiply, the base stays the same and I add the powers. When I divide, the base stays the same and I subtract the powers. So on this one, what I end up with is I end up with the base staying the same, h, and then I end up with a 7 subtract 2. 7 take away 2 is 5. And you can see that happening there as well because I end up with a h times a h times a h. 7 of them here. 2 of them on the bottom. And when I cancel out, it's the same as taking them away. So I cancel one there, whoop, and I cancel one there. And what I am left with is 1, 2, 3, 4, 5, h to the power of 5 is my answer there. To simplify, when you have brackets, the easiest way is to look at it as one of these questions. Because what I have is brackets cubed, means that that's x squared times by x squared times by x squared. So whatever's inside the bracket, cubed. Multiply by itself 3 times. Now, the rule we said here was that when the base is the same, they're all x's, the base stays the same, and we add the powers, 2, 4, 6. And that's your answer. And the reason you get that again is because I have x times x multiplied by x times x multiplied by x times x. So you can see what I end up with. 1, 2, 3, 4, 5, 6. 6 x's all multiplied together gives me x to the power of 6. 3 marks for some simple rules involving indices. Alright, question 9, again, I'm going to remind you, as soon as you see this, you need to make sure you're being very clear on your working and showing the work you're showing. On Monday, so Mr. Smith drives 24 miles to work. On Monday, his journey takes 30 minutes. On Tuesday, the average speed of his journey to work is 56 kilometers per hour. Did Mr. Smith drive more quickly to work on Monday or on Tuesday? You must show all of your working. You know what? This is actually a ridiculously easy question for 4 marks. What you need to do is, at the minute I've got how long it took him, and in the other one I've got a speed. So I'm going to try and get both speeds that he travels at, so that I can just sit there and make the decision on which one he drove quicker on. And the way to do that is, this is 56 kilometers per hour. So what I want to know is, I want to know how quickly did he get to 24 if it only took him 30 minutes. And that's really easy, because what he did is he traveled 24 miles per 30 minutes, which means if he had kept on at exactly the same speed, he would have travelled 48 miles per hour. I just doubled it. So that's easy. Now, if I went and just compared the 48 miles per hour, the 56 kilometres per hour, then at this point, I'm going to be wrong. Because again, although I've got both speeds, I've got speeds in 2 different units. So what I need to do is I need to now compare 48 miles to kilometres per hour. So I can convert either way. And remember, we said this before, is that the conversion to remember is 5/8. That's an important measurement. That's the conversion between miles and kilometres that you need to be using. And so what I'm going to do is I'm going to convert my, well, either way it makes no difference, but I might convert my miles per hour into kilometres. So to convert miles per hour into kilometres, I'm going to end up with more kilometres. So I'll end up with a bigger value. So to do that, what I do is I need to divide that by 5 and times it by 8. The length is at 5/8, so I'm going to divide that by 5 and times it by 8. So what I end up with is 48 divided by 5, and divide by 5, what I'm going to do is I'm going to divide by 10 and double it. So I'm going to divide by 10 is 4.8, and double that is 9.6. There we go, so that's 9.6, and then what I'm going to do is I'm going to take that 9.6 and times it by 8. And the times by 8, what I do is I'm going to double it again, and double it again. Times by 2, by 4, and then by 8. So I end up with 9.6 doubled gives me 19.2, and then doubled is going to give me, double that is 38.4, and then I'm going to double that again. I'm going to get 38.4 doubled is 76. I'm struggling. So freeze. 76.8 kilometres per hour. So what you can see is clearly he's travelling faster on Monday than he is on Tuesday. Done. So you do that calculation. No questions? Sorry, I was going to ask questions. I'm recording. All right. Next question. Looking at nth term and expressions. So here are the first 5 terms of an arithmetic sequence. Write down an expression in terms of n for the nth term of this sequence. So the n is kind of like when you think about those straight line graphs. The n, the number you put with n is how much the pattern changes by each time. It's kind of like a gradient. So here it goes up by positive 4, positive 4, positive 4, so it's 4n. The positive 4 goes with the n. And then if I was to go back a term, here to the 0 term, what I'd end up with is I'd end up with a positive 2. And so I just write plus 2. That's it, done. That's the nth term. That's the expression now that if I use it, will tell me what the next term is. So here, very quickly, if I wanted the 6th term, I'd do 4 times 6 is 24, plus 2 is 26. And you can see the next one is 26, going up by 4s. The nth term of a different sequence is 2n squared, take away 4. Find the third term. So you're going to do the same thing that I did in the last one. You're doing some substitution. So here I've got 2n squared, take away 4, which is 2 times, and I want the third one, so I'm going to substitute 3 for the letter n. 3 squared, take away 4. Please be very careful. Make sure you follow, when you do a question like this, your bid mass. It's a non-calculator paper. Are there brackets? No. Is there indices? Yes. 2 times 9 take away 4. 3 squared is not 6. Division? No. Multiplication? Yes. 18 take away 4. And addition and subtraction. So here, 18 take away 4 leaves me with a number with value of 14. And that's my answer. That's the third number in that sequence, in that particular pattern. So that describes the pattern where the third number will be the number 14. Okay, having a look at this regular decagon. There's two things. The word regular, as soon as you see that, you know that each one of these sides around the decagon, 10-sided shape, are all exactly the same length. And you know that each of the angles in there are all exactly the same size. So what we do is that word regular is really, really important. A regular triangle is just an equilateral. A regular quadrilateral is a square. Regular means that all the sides are the same length and all the angles are the same size. So what we have here in a regular decagon is that's the same length as that. So what I end up with is I end up with an isosceles triangle. So I know that that's x as well. And then what I've got is if I could work out what the size of this angle is, I'll be able to work out what's left and be able to work out the size of x. So that regular word is crucial. To work out the size of this, I'm just going to talk patterns with you. So I'm going to talk the fact that a triangle has an angle sum of 180. A square has an angle sum of 360. All I did is add 180. A five-sided shape, which is a pentagon, has an angle sum of 540. Again, I'm just adding 180. A six-sided shape, add another 180, has an angle sum of 720. I'm adding 180 on really quickly because all I'm doing is adding 200 and subtracting 20. So I've gone 380 take away 20 is 360. 560 take away 20 is 540. 540 plus 200 is 740. Take away 20 is 720. And I need to keep going on that pattern of adding 180 to each additional side the shape has until I get to this 10-sided shape. That'll tell me what all the angles inside that shape add up to. So in this case, I've got 720, 900, 1080, 1260. Again, I'm going to go 1440. So that is the angles in there. 10-sided regular shape means that they're all exactly the same. So all I do is I take the totals that they add up to, which is 1,440, and in this case I just divide it by 10. So at a single angle, each angle is 1,440 divided by 10, which is 144 degrees. Done. That's easy. So I know now that that's not just an angle I don't know, it's 144 degrees. And if I know that's 144 degrees, I know that angles in a triangle add up to 180, so I'm left with 36 degrees for these two. And if they're both the same, because it's an isosceles triangle, then I just halve that. Which means I get that here, 180 take away 144 is 36 degrees. And if I was to give a reason for that, it is angles in a triangle add to 180. And then I'd say that 36 divided by 2 equals 18 degrees. And the reason I say that is because I know that those base angles of an isosceles triangle are equal, done. So that's my final answer, is 18. So you go through those steps, and if you have a look at it, the reason that it's worth 4 marks to go through and do those steps. Question 12. Prove that the most ridiculous looking equation is equal. So basically what you're going to do is you're going to sit here and you're going to try and say, right, what can I do with this to try and make it look like that? That's what the question's asking, really. What can you do? Can you show that that side equals the other side? And to do that, I'm going to start off and I'm going to go through and I'm going to do a few calculations on it. So that what I'm going to do is I'm going to expand. So the first thing I'm going to do is there's no brackets over this side, but there's brackets over this side. So I'm going to expand out each of those different bits. And to do that, I'm going to need to use FOIL, because I've got n take away 1 squared, and I've got n plus 1 squared. So I'm going to do, first of all over here, I'll do n take away 1 squared, which is just n take away 1 times n take away 1. That's squared. That's n take away 1 multiplied by itself. And I'm going to use FOIL. So I get first, which is n times n, which is n squared. I get the outer, which is n times, be very careful, it's a negative, so minus 1, which is minus n. I'm going to get the inner, which is minus 1 times by n, again, minus n. And then I'm going to get the last, which is the minus 1 times by the minus 1. First time really we've come up against one of these negative multiplications. But just go through the pattern of what we were doing before. 1 times 1 is 1. 1 times minus 1 is minus 1. So minus 1 times minus 1, negative 1 times a negative 1 will give us a positive 1 again. Each time we multiply by another negative, it just flips the sign over and over. So we get a positive 1. So what that becomes is n squared take away n plus 1. Which I can simplify to n squared. If it's negative 1, it gets 1 degree colder, it becomes negative 2. There we go. So that's that one expanded out. Now I'm going to expand out this one over here. N plus 1 squared. Again, like the last one, n plus 1 squared is just n plus 1 times n plus 1. And then I'm going to use FOIL. First, n times n. Outer, n times 1. Inner, 1 times n. And the last, 1 times 1. Means I get n times n is n squared, n times 1 is n, 1 times n is n, 1 times 1 is 1. That's much easier, there's no negatives, so when there's no negatives it does make it easier. Which gives me n squared plus n plus 1. Which when I simplify it is n squared plus 2n plus 1. So now what I've done is I've expanded out all the brackets. If I was then to write that out, which I'm going to do now, as n squared take away 2n plus 1, I was to say plus n squared in the middle there. I was then to write this expanded out, plus n squared plus 2n plus 1. I was to write that out, and then I was to say, well, let me try and collect all the things that are the same. Let's try and simplify it down and see if it looks easier. What I end up with is I end up with n squared plus another n squared plus another n squared, which is 3n squared, which actually kind of matches. I then sit there and I say, okay, well what about the n's? I've got negative 2n plus 2n. Right, if I've got negative 2n plus 2n, it's negative 2, gets 2 degrees warmer, it becomes 0. So nothing n. So actually, those two cancel each other out. And then I end up with a positive 1 plus another 1 gives me a positive 2. So I use those ones and collect those. And actually, what I see is I see that. And I get that. So it's actually a real lot of stuff there. But actually, when you think and break it down, there's two simple expansions. The trick there is to have a look at the fact that there's a heap of brackets sitting on this side, and there's no brackets on this side. So I'm going to have to try and get rid of all the brackets out of it, expand it away. Right, question 13. Give reasons for your answers, so you need to make sure you're given reasons. It's got the little asterisk there, so be careful, show clearly. S and U are points on the circumference of a circle, centre 0. ST and UT are tangents, angle STU is 42 degrees. So work out the size of angle SOU. You know what, this is ridiculously easy for this particular question. The first thing you should know is you should know that that is a right angle. You should be able to see that. It's a tangent that's meeting the radius of a circle. And you know that angle TSO is actually exactly the same as another angle that's on there. It's the exact same as TUO. Which equals 90 degrees. And I know that because I'm going to give a reason for it, and that is that the tangent, so I'm using some key words there, meets the radius at 90 degrees. Or you could have said the tangent is perpendicular to the to the radius. Or you could have said that the tangent and the radius make a right angle. I don't mind what you say as long as you use the word tangent, as long as you use the word radius, and as long as you say the fact that it's 90 degrees, using either the word perpendicular, 90 degrees, or right angle. And once you've got that, you then know that that's 42, that's 90, so I can work out the angle SOU I'm being asked in the question because I have myself a quadrilateral. And I know that in a quadrilateral they add up to 360, and all I do is I take away the 90, and another 90 for here, and the 42. So I get that angle SOU, I should write that in, angle SOU, so this angle in here, equals 360, take away the 90, take away the 90 is 180, take away 42, leaves me with 138 degrees. And I have to give a reason for that, and it's just that angles in a quadrilateral add to 360 degrees. That's it, done. So actually, you're going to get the marks for those circle theorem and then just knowing the angles in a shape. So take your time on those questions, have a good look at it, think about what you know, think about what the information is telling you. It's the same as when you get an angle problem and you see parallel lines. You know there's certain rules you're going to be having to use in that question, so look for where you can use those rules and see if it's going to help you get what you're being asked to find. And question 14 is looking at surds. Express 5 square root 27 in the form n to the square root of 3. So what I'm trying to do is I'm trying to get this to be the square root of 3. Now, the good thing about surds is what it is, it's actually 5 times the square root of 27, and I can break that 27 down. If I know a square root value that's going to work and give me a whole number, then I can use that instead. So actually, 5 times, instead of the square root of 27, I'm going to go to the square root of 9 times the square root of 3. The reason I'm going that is because I actually already know what the square root of 9 is. I know that the square root of 9 is 3 times the square root of 3. So what I've done there is, all I've done is I've got the number 27, I know that it's 9 times 3. And that's useful because I know the square root of 9. That's it. So here, what I end up with is 5 times 3, which is the whole number, which is 15, times by root 3. So that equals 15 root 3. So my answer for this question in the form of n to the root 3 is just 15 to the root 3. That's it. That's that question. And I use the fact that I know the square root of 9 is 3. Rationalising the denominator, we've talked about this before, 21 over the square root of 3 times by, and I just multiply it by the square root of 3 there. So what I end up with is I end up with 21 times by the square root of 3 over square root of 3 of square root of 3 is 3. Now I should simplify that if possible, and I know that 1 3 goes into 21 7 times. So I end up with 7 root 3. Done. So So it's just simplifying. That's my answer on that. This is some indices work. Write down the value of 27 to the power of third. That's the same as saying what's the cube root of 27. So what number do I multiply by itself 3 times to get 27? Well, 3 times 3 is 9, times 3 again is 27. So the answer there is actually just 3. What number do I cube? What number is 27 cube root, or what number do I cube to get 27? And then find the value of 25 to the power negative a half. It's going to be the same thing. It's going to be 24. It's going to be the square root of 25, but because it's a negative half, it's 1 over the square root of 25, which in this case is 1 over 5, 1/5. The square root of 25 is just 5. And just the last part of this. What have we got? Last question. I'm going to simplify this. I'm going to do it by factorization. I get 2 times y is 2y, and 2 times minus 6 is 12. 2 times minus 6 is 12. I'm going to factorize this, which means I'm looking for a number that will multiply to 12. A pair of numbers when they multiply to 12. So 2 numbers that multiply to 12 and add to negative 8. And so those 2 numbers that I'm going to do are... I can't stop the recording. Oh! Sorry, sir. So what I end up with, 2 numbers that multiply and divide, is going to be negative 6 and negative 2. So here is going to be y take away 6, y take away 2. It simplifies because I've got the same bracket on the top and on the bottom. So I end up with 2 over y take away 2. And for the very last question of the whole paper, I'm just going to do it very quickly. And we're going to blame Miss McCartney for that. I'm just going to swing the door for 2 seconds. Last question, write as a single fraction. What I'm going to do is, this is a negative here, so I'm going to combine them, and to do that I'm going to do the cross multiplying that we've done before, which is that times those, and then this times those, which is really easy. I end up with 3 times x plus 5 over, take away x take 4, and then this becomes x take 4, because these are cross multiplied by each other, x plus 5. That's the paper, 60 marks. You need to be making sure you go over and practice it. I know it gets difficult towards the end with some algebra skills, but practice and you'll get there. Cheers.